Hello everyone. So this is a question from NEET 2026. The pair of molecules that are metamers, okay, important metamers, among the following is, so we have CH3, CH2, CH2OH and CH3, CHOH, CH3. We have CH3, CH2, CH2, CH3 and CH3 twice, CH, CH2 and CH3. We have CH3CO, CH3 acetone and CH3CH2CHO, CH3O, CH2, CH2, CH3, and CH3, CH2O, CH2, CH3. Okay, so the chapters involved is general organic chemistry. We know that two or more compounds having the same molecular formula but different chemical and physical properties are called isomers. We know this. Okay, so two or more compounds having same molecular formula but different chemical and physical properties, so they are known as isomers. Okay, and isomers are of two types. We have structural isomers and stereoisomers. Okay, cool. So structural isomers are, structural isomerism are compounds having the same molecular formula but different structures. Okay, that is different arrangement of atoms within the molecule. Very important. So structural isomers are compounds having same molecular formula but different structures. By different structures, I mean different arrangement of atoms within the molecule. Okay, so it is of six types. So we have chain, second is position, third is functional, fourth is metamerism, fifth is tautomerism, and sixth is ring chain. Okay, so we have to discuss about this guy, metamerism. Okay, so compounds having the same molecular formula but different number of carbon atoms or alkyl groups on either side of the functional group are said to show metamerism. Very important. Compounds having the same molecular formula, obviously, but different number of carbon atoms, or you can also say, alkyl groups, different number of alkyl groups. Alkyl groups are formed, when we remove one hydrogen from alkenes. Okay, so compounds having the same molecular formula but different number of carbon atoms or alkyl groups on either side of the functional group. Very important. On either side of the functional group. So there are certain conditions for compounds to show metamerism. So metamerism occurs exclusively in compounds with polyvalent functional groups. Very important. Metamerism occurs exclusively in compounds with polyvalent functional groups. Okay, so by polyvalent I mean functional groups with two or more than two valency. Very important. When I say polyvalent, I mean those functional groups which will have two or more than two valency. More than two valency. Example, for example, we have divalent oxygen. You can see here, these are the two valencies. We have this guy. You can see these are the two valencies. Okay. For example, NH. You can see these are the two valencies. For example, the carbonyl group. These are the two valencies. Okay. So the for metamerism to occur, the functional group should be polyvalent. That is, it should have two or more than two valency. Okay. So in a nutshell, we can say that in metamerism, the molecular formula and the central functional group remains identical. Obviously, the functional group remains identical in both the compounds, but size of the carbon chain or the alkyl group attached on either side vary. For example, in both the compounds, let's say we have this functional group, so they will contain different number of carbon atoms on either side of the functional group. Okay. Similarly, in the case of this carbonyl group, so both the compounds will contain this functional group, but they will contain different amount of alkyl groups or carbon atoms on either side of the carbonyl group. So in a nutshell, we can say that in metamerism, molecular formula and central functional group remains identical, but size of the carbon chain, or you can also say the alkyl group attached on either side, vary. Okay, so now we can look into the options one by one. So let's look into option A. Option A, we have CCCOH and CCOH and C, right? So in A, both of them have, I forgot to add the hydrogen, one second, CH3, CH2, CH2OH and CH3, CH, CH3. So both have the same molecular formula, that is C3H8O. Okay, but they have different structures, as we can see, this and this. So therefore they show isomerism, no doubt about it, but it cannot be metamerism because the functional group is OH here and it is monovalent. What is the condition for a functional group to show metamerism is that it should be polyvalent. It should have at least two valencies on either side, for example O or S. But OH is monovalent, it has just one valency, so therefore it cannot have different number of carbon atoms on either side of it. Okay, so both of them are actually position isomers. Okay, they show position isomerism because they have the same structure of carbon chain. You can see the carbon chain is same, consisting of 3 carbon atoms, but differ only in the position of OH group. Here the OH is in the first carbon, here the OH is in the second carbon. Okay, cool. So A cannot be the answer. Then we have option B. In option B, we have CH3, CH2, 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 CH3, and CH3, CH, CH3, CH2, CH3. Okay, in option B, both have the same molecular formula, that is C5H12. But different structures. They have different structures. Both of them have different structures. Okay, so therefore they show isomerism, but it cannot be metamerism because there is no polyvalent functional group in them. There is no functional group at all. Okay, both of them are alkenes, and it is actually chain isomerism because they have different arrangement of carbon chain within the molecule. You can see here the main chain consists of 1, 2, 3, 4, 5 carbon atoms, and there are no side chains. But in this, the main chain consists of 1, 2, 3, 4 carbon atoms and one side chain, one methyl side chain. So therefore they are chain isomerism. Or you can say they show chain isomerism. Next we have CH3, C double bond O, CH3 and CH3, CH2, C double bond O, H, right? So both have the same molecular formula, that is C3H6O, but different structures. Obviously the structure is different, so therefore they show isomerism, they are isomers, but it cannot be metamerism because both have different functional group. One contains this CO ketone group and the other contains this CHO, that is the aldehyde group, right? For metamerism, the central functional group, okay, should remain identical as we have discussed. Just the number of carbon atoms on either side of the functional group vary. For example, let's say we have the functional group divalent oxygen, so the number of carbon atoms should vary. The functional group should remain same in both of them, but here the functional group itself is different. Okay, so therefore these guys are actually functional isomers because they have the same formula but different functional group. So these are actually functional isomers. One is a ketone, the other one is a aldehyde. And the last option is CH3O, CH2, CH2, CH3 and CH3, CH2O, CH2, CH3. Okay, so both have the same molecular formula, that is C4H10O, but different structures. Obviously both have different structures, therefore they show isomerism. It contains divalent oxygen, that is this guy, as the functional group, and so it is polyvalent. Okay, it has two valencies, you can see here. Okay, also the number of carbon atoms on either side of the divalent oxygen are not same in both of them. For example, in the first one, divalent oxygen left hand side have one carbon atom, right hand side has 1, 2, 3 carbon atom. So 1 and 3. In the second case, divalent oxygen has two carbon atoms on the left hand side and two carbon atoms on the right hand side. So 2 and 2. Or you can also say that divalent oxygen has different alkyl group. Here we have CH3 as the alkyl group on the left hand side. Here we have CH2, CH2, CH3 and propyl. In the second case, we have ethyl on the left hand side as well as ethyl on the right hand side. So different functional group. So therefore these two are metamers because they have polyvalent functional group, that is divalent oxygen, and also different number of carbon atoms on either side. So therefore these two are metamers. So therefore the correct answer will be D. A pair of molecules that are metamers among the following is D. Okay, thank you.